Alright guys, today we're going to do terminating decimals, recurring decimals, and rounding. So have a look at these three fractions here. We know that fraction can be converted into decimals, but not all fractions convert into the same type of decimals, right? For example, the first one, 1 over 2, half. Half is equivalent to 0.5. 1 divided by 2 is 0.5, so it's stopped. And we call that decimal is the terminating decimal. From the name, I suggest it just stopped, right? So 0.5 is terminating decimal. However, for the second example, 1/3, we have 1 divided by 3, and then the answer is 0.333333, and it goes on. Where, as you can see, the decimals that continue forever with some sort of like a pattern, and we call that repeating or recurring decimals. Okay, all right, and the last example is 1 over 7. 1 over 7. 1 divided by 7, and if we do the calculation using long or short divisions, we get 0.142857 and goes on. As you can see, there is no pattern here, so this one is neither terminating decimals or recurring decimals. All right, so we probably need to know how to do the rounding for this type of questions here. All right, so we need to be able to do the rounding. And as well as we need to be able to do the rounding for the recurring decimals as well. All right. Okay, so what is the definition of a terminating decimals? A terminating decimals has a finite number of decimal places. So basically it terminates. So we know a certain fraction, like for example 5 divided by 8, we can do a long division, and then the decimal stop at a certain decimal place. So we'll start with the definition here first. All right, so terminating decimals has a finite number of decimal places. All right, so let's use an example here, 5 divided by 8. Okay, so 5 over 8 is equivalent to 5 divided by 8. And what does that equal to if we use a long division, for example? So we'll have 5 and 8 here. So the first number is going to be 6, 48, 20, and 2, 16, 40, and 5, 40, and that becomes 0. So as you can see, the decimal numbers stop at the third decimal place, right? So 0.2625 is equal to 5 divided by 8, or 5 over 8. And we call that terminating decimals, all right? All right, then what is the definition of recurring decimals? So that's terminating decimal. Recurring decimals, or repeating decimals. All right, recurring decimals has an infinite number of decimal places with a finite sequence of digits that are repeated indefinitely. So it has an infinite number of decimal places. That's the first thing you need to remember. So it never stops, basically, with a finite sequence of digits that are repeated indefinitely. So that just means a recurring decimals has an infinite number of decimal places, and does have some pattern. All right, so in an example here, I would like to show you is 2 over 3, for example. 2 over 3 is 2 divided by 3, and if we try to use a long division, let's see what happens. So we've got 2 divided by 3, 0 point, and then that'll be 6, 18. If you do subtraction, that'll be 2 again, so it'll be 20, so it'll be 6 again, it'll be 18 again. So as you can see, we can continue this one forever. And you always get a remainder of 2, and then you can always add in a 0 at the end. So the answer will be 0.66666, and it goes on. All right. So as you can see, it has an infinite number of decimal places. This has a pattern here. The pattern is 0.6 recurring, and then it repeated indefinitely. Okay. Something that you need to remember is all terminating and recurring decimals can be expressed as a fraction. Okay, so all numbers that can be expressed as a fraction, like a divided by b in this kind of format. All right, so for a recurring decimals, what is the convenient way to show or to write a recurring decimals, right? Because sometimes you do get a recurring decimals like 0.585858 and repeating. Now, this is not an inconvenient way to write a number like this, right? You don't want to write 5 and 8 or 10 times. So what is the best way to write it? We do have a way to write it, recurring decimals. So we use dots. Okay, so if, for example, 2 digits repeating themselves, the way we do it is we write 0.5 and 8, and we place 2 dots on top of the number 5 and 8. These are the 2 digits that are repeating themselves. Okay. And that just means 0.58 and 5 and 8 are repeating themselves, right? That's the way we do it. What about if we have like 3 numbers or 3 digits that are repeating? So 0.123, 123, 123. What do we do in this case? Do we still put 3 dots on top of the numbers? Like this. Do we still do it like this? The answer to that is not really, okay? That just means like if we have like, for example, 5 digits that are repeating themselves, do we put like 5 dots? No. All right, we don't put 5 dots. So what do? What we're going to do here is we're going to put dots placed above the digits to show the start and finish of a repeating cycle of the digits. Okay? So start and finish. So if it's a 0.123, if 1, 2, 3 are repeating themselves, right? So this is what we need to do. So we'll write 0.123 first, and then we'll place a dot at the start of the number, all right? Start of repeating digits, which is 1, and we'll put a dot at the end. All right, so that's how we do it. So that way it's just slightly easier to write down 0.123, and we'll place 3 dots on top of each of the number here. All right. Is there another way we can do it? Yes, there's another way we can do it. Another convention is to use a horizontal line. All right, we're placing the horizontal line above the digits to show the repeating cycle of digits. All right, so this one is also equal to 0.123, and we'll just put a line on top of the 3 numbers that are repeating themselves. All right, so I'd like to show another example. 0.3412121212. All right, so what do? With this one here, as you can see, that 3 and 4 does not repeat in itself, but 1 and 2 does, right? So if we're using the dots, it would be 0.3412, and we'll place 2 dots, 1 on top of 1 and 2, or we can put a bar or a line on top of the number 1 and 2. So 0.3412, and we'll place a bar on top. So that's how we do. Okay, all right, so the next one I would like to do is the rounding decimals. How do we do the rounding? All right, rounding decimals involving approximation, okay? It's involving approximating a decimal number to fewer decimal places. Does depend on the question. Sometimes they ask you to round to 1 decimal place or 2 decimal places or 3 decimal places. Depends on the question. But there are some general rules that you do need to know. Rounding decimals. All right, so when rounding, the most important thing is that we're looking at the critical digit. The critical digit is the digit immediately after the rounding digit, okay? So, let me just give you an example here. So if we want to round 0.62517 to, let's just say to 2 decimal places. All right, to 2 decimal places. So, so what is the critical digits? Let me rewrite the number first. All right, so the first thing you do is you look at the two decimal places, right? So that's 1, that's the first one, and that's the second one. That's the two decimal places. So basically what I will do here is I'll just draw a line here to separate the numbers. Now, which one is the critical digit? Okay, which one is the critical digit? The critical digit is the digit immediately after the rounding digits. So that's the rounding digits here. Because it says like in two decimal places. So the rounding digits and the critical digits can change, depends on the question. All right, so that's the rounding digits. Now, immediately after the rounding digit is the critical digits, which is the digit here. So that one. And that's the reason I usually just draw a line to separate the critical digit and the rounding digit. All right, now you need to follow that rule. If the critical digit is less than 5, then the rounding digit is not changed. Okay, so if it's less than 5, then you don't have to worry about changing anything. Okay, so let me just write this one down. So if the critical digit is less than 5, the rounding digit does not change. All right, obviously it's not the case here because the critical digit is equal to 5, okay? So what happens if the critical digit is equal to 5 or more? So like a 5, 6, 7, 8, and 9, what do we do? If the critical digit is 5 or more, then the rounding digit is increased by 1. So it's pretty straightforward. Is 5 or more, then the rounding digit is increased by 1. Alright, so this one is quite straightforward here. So if you look at our question here, we want to round 0.62517 to 2 decimal places. Then the way we'll do it is we'll look at the digits, and the critical digit is equal to 5. So according to the second rule here, we are going to plus 1 to the rounding digits. So therefore, the answer to that question is equal to, approximately equal to 0.63. And that's to 2 dp, so 2 decimal places. All right? All right, so I'd like to show you a few more examples with rounding digits. Something that's a bit interesting. So let's do the first one here. 0.98. 0.98. And the question asks you to round to, how about 1 decimal place? Yes, 1 dp. All right, so how do we do this question here? Well, the first thing you do is you just have a look at the numbers here, right? Which one is the critical digit and which one is the rounding digit. All right, so 1 decimal places, that's 1 decimal places here. So draw a line, and as you can see, this number here is the critical digit, and that number is greater than 5. All right, so what we need to do is we need to plus 1 to the previous digits, or plus 1 to the rounding digits. However, if you plus 1 to 9, what do you get? 9 plus 1 is 10. All right, so how do we do it with this one? It's 10. That means you have to plus 1 to the previous one more time. So therefore, when you round that number here, it is equal to 1.0. Now you have to write 1.0. All right, because that shows it's 1 decimal place. You can't just write 1. Also, 1.0 is sort of equivalent to 1, but the accuracy, or the degree of accuracy is different. Okay, so it's 1 decimal places, you write 1.0. That's how you do the first question here. Very interesting. All right, so how about the second one? So for the second question, all right, how about this one here, 0.0015, and then the question asks you to round to 2 decimal places, okay, 2 decimal places. Another really interesting question here. All right, so let's have a look. So the 2 decimal places, draw a line here, and then the critical number or the critical digit is equal to 1. All right, 1 is less than 5, that means you don't have to do anything else, all right? So that is roughly approximately equals to 0.00. Yes, you need to write 0.00 to represent 2 decimal places. Okay, very important. All right, let's do one more. What about 78.9963 and two decimal places? All right, so let's just do the same thing, and then let's label the critical digits here, and that's equal to 6, which is more than 5. That means we need to plus 1 to the previous number, and however, that's, the previous digit is 9, which gives you 10. That means you have to plus 1 again, and that's 10 again. So you have to keep going, plus 1 again. So when you do the rounding, that answer will be 79.00. And that will be the answer for round this number to 2 decimal places. And that's how you do this question here. All right, so that's it for this lesson. All right, all you need to remember is how to, what's the difference between the terminating decimals and the recurring decimals, and how to do the roundings with decimal numbers. Okay, thank you.